The ability to scale abstractly written compute intensive programs across large distributed compute environments is a key factor in the success of modern machine learning. This is crucial for machine learning computations involving large language models, which are often too large to fit on a single compute node. Another key facet of modern ML software is the general ease with which computations can be written and optimized. There are various techniques which are already available, just like just in time or JIT compilation, that have enabled frameworks such as PyTorch, TensorFlow, and also JAX to scale to larger and more complex ML workloads. This is where this new research, FAX, can make a huge difference. FAX is a software library that brings the benefits like sharding, easy to use JIT compilation, and AD. AD stands for automatic differentiation, to the types of computations used in federated learning. Federated learning is a distributed learning paradigm in which clients collaborate on a machine learning tasks without sharding data. This means that computationals for federated learning, which in this paper are also called as FL, often involve many clients training models in parallel with periodic synchronization. This paper has been produced by Google and they also have a pretty cool GitHub repo. Installation of FAX is quite simple. If all you need to do is to just do pip install and Google dash FAX and you're off you go. You just need to clone this GitHub repo and you can also execute some of the tests if you are in the mood. Now, these applications are quite interesting. And let me touch a little bit on the system design of FAX. FAX is designed with two key ideas in mind. First, most federated computations can be built from subroutines already integral to distributed ML workloads. An observation drawn from the programming model of TensorFlow Federated. What separates FL from ML is an accounting of where data lives and which subroutines require privacy safeguards. Secondly, they have implemented federated AD by combining standard AD techniques, which includes computation graph and few other things, for in-depth discussion of a lot of other things. Now, to do this accounting, FAX operates on federated values. These are values coupled with a data location called the value placement, and they consider two placements, client placed and server placed. They also have assumed that there are potentially many clients participating in a given computation, but only a single server. They denote a federated value where a lot of mathematical equations they have given, and I won't go into the details of that. So, and they have implemented it in quite a nice way. They have described the whole implementation process also in this paper. If you go here and go to RFX, and also they have a full-blown paper by, if you click on view PDF, you can also check out this paper where they have represented these FAX implementation, and also in particular how it represents federated values and implements federated computations on set values. They have also discussed how they ensure FAX computations are effectively sharded across data center runtimes and how FAX can implement federated AD. So pretty cool research. I think this will be really good in this resource constrained world. So I would really like to see some sort of implementation of this FAX in some of the models, or maybe in the fine-tuned ones. As soon as I get my hands on it, I will make another video with some of the hands-on stuff. I will drop the link to this Hugging Face page of this paper so that if you want, you can read through. And if you like the content, then please consider subscribing to the channel. If you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.